Assalamualaikum and hi, we are from Group B. I am Nur Asmani Babiti Johar and my meeting number is EFT1083. Let me introduce to my group members. Let's start with member 2.
Hi, I'm Hiroshi, Dr. Balasubramanian. I'm number 2 in this group. My meeting number is F22B0130.
Hi, Assalamualaikum. My name is Jeli binti Ismail and my metric number is F22B0151 and I am member 3.
Assalamualaikum. My name is Muhammad Nasraf Beitus and my matrix number F22A0202 and I am member 4.
For our assignment project, we had chosen our scope that was Jeli campus classroom. Problem title for one part is student conducting experiment with water tank. In our classroom, a student is conducting an experiment with a water tank. The water level in the tank is changing over time and the student will analyze the rate at which the water level is decreasing. The height of the water level at t time is given by the function ht. Where t is measured in minutes and ht is measured in meter, the function ht is differentiable. The student measured the height of the water level at various points in time. Information was given. For question A, determine the average rate of change of the water level between t is equal to 0 minute and t equal to 6 minutes. For question B, to calculate the instantaneous rate of change of the water level at t equal to 3 minutes, we need to find the derivatives at the height function ht at t equal to 3. For my solution is A. To determine the average rate of change of the water level between t equal to 0 minute and t equal to 6 minutes, we can use the formula average rate of change equal to change in height per change in time. The change in height is the difference between the initial and final height. That was h6 minus h0 equal to 2 meter minus 5 meter. Then we will get the answer negative 3 meter. Then the change in time is 6 minutes minus 0 minute. The answer we will get is 6 minutes. Therefore, the average rate of change is negative 3 meter per 6 minute equal to negative 0.5 meter per minute. So, the average rate of change of the water level is negative 0.5 meter per minute. For my solution is next, for the solution B, to calculate the instantaneous rate of change of the water level at t equal to 3 minutes, we need to find the derivative of the height function ht at t equal to 3. From the given, t equal to 3 minutes, h3 equal to 3 meter. The instantaneous rate of change at a specific time t can be found by taking the derivative of the height function ht with respect to time t and evaluating it at t equal to 3. So, we need to find h prime 3, which represent the derivative of ht at t equal to 3. H prime t equal to dht per dt. To find h prime t, we can use the information given about ht at t equal to 3 and nearby points to estimate the derivative using finite differences. Since we have data for t equal to 0, 3 and 6 minutes, we can use the following formula. H prime t estimate h6 minus h0 per 6 minus 0. Then we rewrite it h prime t estimate to 2 meter minus 5 meter per 6 minutes minus 0 minutes. Then we get the answer h prime t to negative 0.5 meter per minute. Therefore, The estimate instantaneous rate of change of the water level at t equal to 3 minutes is approximately negative 0.5 meter per minute.
So this is the problem. In my university classroom, the professor is writing on the whiteboard using a marker. The height of the marker above the floor at the time t is given by the function ht, where t is the time in seconds and ht is measured in meters. The function of ht is differentiable. So the professor starts writing at t equals to 0 and finishes at t equals to 10. The height of the marker above the floor changes according to the derivative of the function dh slash dt, which represents the velocity of the marker in meters per second. So for my problem's question is, first, determine the velocity function dht slash dt that describes the movement of the marker. Second of the questions, calculate the average velocity of the marker between t equals to 2 seconds and t equals to 8 seconds. So this is the solution for question number 1.
Question number 1. To determine the velocity function dht over dt, we need to find the derivative of the height function, which is ht with respect to time t, denoted as dht over dt. So let's assume the height function is given by ht equals a t2 plus b t plus c, where a, b and c are constants. Taking the derivative of ht with respect to t, we get dht over dt equals 280 plus b. Thus, the velocity function dht over dt that describes the movement of the marker is given by dht over dt equals 280 plus 2b.
This is the solution for question number 2.
To calculate the average velocity of the marker between t equals 2 seconds and t equals 8 seconds, we need to find the total change in height over that time interval. Using the velocity function dht over dt equals 280 plus b from part A, we integrate it with respect to t to obtain the height function ht is to ht equals at2 plus bt plus d, where d is a constant of integration. Since we know that the marker starts writing at t equals 0, we can substitute t equals 0 into the equation. Is to h0 equals a02 plus b0 plus d equals d. Thus, the height function ht is given by ht equals at square f2 plus bt plus h0. Now we evaluate the height function at t equals 8 and t equals 2, which is h8 and a8 square 2 plus b8 plus h0 equals 64a plus 8b plus h0. h2 equals a2 power of 2 plus b2 plus h0 equals to 4a plus 2b plus h0. So the total change in height between t equals 2 seconds and t equals 8 seconds is h equals to h8 minus h2 equals 64a plus 8b plus h0 minus 4a plus 2b plus h0 equals to 60a plus 6b. The total time elapsed between t equals 2 seconds and t equals 8 seconds is 8 minus 2 equals 6 seconds. Therefore, the average velocity is average velocity equals to h over t equals 60a plus 6b over 6 equals to 10a plus b. Hence, the average velocity of the marker between t equals 2 seconds and t equals 8 seconds is 10a and b. Please note that the values of the values of A, B and HO could be determined if additional information such as the initial height of the marker is provided.
My problem is randomly changing seating arrangement. In my university classroom, my professor has a habit of randomly changing the seating arrangement each week. This week, there are 30 students in the class, and the seating arrangement follows a specific pattern. The position of each student is represented by a function ft, where t is the time in the minutes since the class started, and ft gives the distance in a meter from the front of the classroom. The function ft is a differentiable. At t equals 0, the professor asks the student to start moving toward the front of the classroom. The velocity at which each student moves toward the front is given by Vt equals Ft, the derivative of the position function. At t equals 5 minutes, the velocity of each student is given by V5 equal 0.2 minutes. For my question number 1, determine the position function ft for the students in the classroom. And for my question number 2 is calculate the average velocities of the student between t equals 2 minutes and t equals 10 minutes. Solution question number 1 is,
to determine the position function ft, we integrate the given velocity function, this, with respect to t, this, where c is the constant of integration. Given that v5 equals 0.2 minutes, we can substitute this value into the equation this, where d is the another constant. Since we know that the students start moving toward the front of the classroom at t equals 0, we can substitute t equals 0 into the equation this. This implies that c equals d. Thus, the position function ft is given by this, where c is a constant.
and solution for question number 2 is,
To calculate the average velocity of the students between t equal 2 minutes and t equal 10 minutes, we need to find the total change in position over that time interval. Using the position function, this, from part A, we evaluate it at t equal 10 and t equal 2. This. The total change in position between t equal 2 and t equal 10 is, the total time lapse between t equal 2 and t equal 10 is 10 minus 2 equals 8 minutes. Therefore, the average velocity is this. Hence, the average velocity of the students between t equal 2 minutes and t equal 10 minutes is 0.2 meter flash minute. The values of C and D could be determined if additional information, such as the initial position of a student, is provided.
My problem is the university is planning to install a new chair in the UMK Jeli classroom. The cost of manufacturing the chair is estimated to be Rm 100 ringgit per chair plus the additional cost of 2 ringgit per square meter of fabric used to cover the chair. The classroom dimension is 10 meter by 8 meter. Determine the rate at which total cost of manufacturing the chair is changing when the fabric cover the area of 50 square meter. For my solution is, first, let denote the total cost of manufacturing the chair as C and the area of fabric used as A. Given, cost per chair is 100 ringgit, cost per square meter of fabric is Rm 2 ringgit, classroom dimension is 10 meter by 8 meter. To find the rate of at which the total cost manufacturing the chair is changing the respect of fabric area, we need to calculate dC/dA, the derivative of the cost function with the respect of the area. First step is determine the cost function. The cost of manufacturing the chair consists of two components. The cost of the chair, which is 100 ringgit per chair, and the cost of fabric, which is 2 ringgit per square meter of fabric used. So the calculation is C, A equal 100C plus 2A. The second step is calculate the derivative of cost function, which is DC divided by DA equal to D divided by DA, 100C plus 2A, which is equal to 2. The derivative of the cost function with respect to the area consists of value of 2. Step 3. Substitute the given area of the fabric. We are interested in finding the rate of change of the total cost when the fabric cover an area of 50 square meter. So we substitute A equal to 50 into the derivative expression, which is DC divided by DA equal to 2. Therefore, the rate at which the total cost of manufacturing the chair is changing when the fabric cover an area of 50 square meter is 2 ringgit per square meter. That's all for.
Thank you.